Hey, welcome back. So, last time we moved a sprite around the screen, and at least in my opinion, that's a really cool first step towards programming your own game. But today we're going to look at something called character set. So, what's a character set? Well, if we look at the Commodore 64 here, so you remember the loop I made a while back? I just wrote every single character in a loop. So basically, this is what I did. I made a loop and I just transferred X to the accumulator and then I stored that. So I stored whatever X was into the memory address at the X offset. Hopefully you remember this one. So basically what's happening here is storing every character here on the screen. So what we're looking at here is actually the character set. So the Commodore 64 character set. So you remember we looked at this web page with the screen codes. And I told you to look at this column. So that's from 0 to 63 down here, and that's 64 to 127 down here. But then there's something called reverse. So that's this column. So we have 127 down here, but then we go back up here, 128, 129, all the way to 191. 192 all the way to 255. So what's that all about? Well, it says reverse here, so that's this one. So this is the character set, same as this one, only reversed. So we talked a little bit about this when we were talking about the screen, the Commodore 64 screen. So this in total is the character set, what we're looking at here, the normal one and the reversed one. And let's see if we can go back here. So in total we have 255 characters. Now we have 100, and since we're starting at 0, we have 128 characters, sort of unique characters, if you could say that. So the other 128, those are the same, only with reversed colors. Hope that makes sense. So the point is that we have 256 characters, and that's the character set. So here I am in the application called CharPad. Now we're going to look at this in detail in the next episode, so I'm not going to show you how to use it now. But it's a really good tool to show you how this works. So here is the character set. You can see we have all the characters here. All the characters, and down here we're starting all over, but with the reversed character set. So all in all, if you could see down here where it says ready now. So if I hold my mouse pointer over the last one here, it says it's character number 255. So since we're starting at 0, we have 256 characters. That's both the normal one and the reversed one. So one character set has 256 characters like this. And of course, just like when we're writing in this application, I can choose a character and just draw with it like that. But like I said, we're going to come back to that in the next episode. The point is that this is a character set. Now let's notice something else here. I'm going to choose the A. So I'm going to choose the A here from the character set. And by the way, when we're saying character set, you'll often see this char set. So the word char set is something that I will be using in my code. char set instead of character set. But here, I've selected the A now. So this is a grid with 8 by 8 pixels. So here I can actually modify what the A looks like. Or I can just say, forget the A. I want to make something cool here. I want to make a smiley face or whatever. So I can make my own characters like that in this 8 by 8 grid of pixels for one character. So what does this mean in terms of storage space? In terms of storage space, the one character in the character set takes up 8 bytes. So, for example, my A in my character set takes up 8 bytes. Now we need to be sure not to be confused, because now we're talking about the graphics for our characters. So what we looked at just a second ago, that was the graphics, the graphic for my A. So each character has their own graphic, and that graphic takes one character takes up 8 bytes. So like we can see here, 1, 2, 3, 4, 5, 6, 7, 8. That's for the graphics for one character. So I can actually just show you how this would work. So here you can see I'm just starting to sort of draw something here. So let's say this was my A. Then you can see over here that it's kind of like when we looked at the sprites. So for a high resolution character set, now we're going to come back to that in a second. But as you can see here, when I put a 1 here, that's a 1 for this bit in the first byte. So just like when we looked at the sprites, maybe you can see my A here made up of 1s. But anyway, hopefully you see the point. One graphic for a character is 8 bytes. 8 bytes. So 1 byte, 2 byte, 3 bytes, 4, and so on. So what was that about high resolution character set? Well, just like with the sprites, we have a high resolution character set, and we also have a multicolor character set. Now, if we go back to CharPad, we can see that our characters here are, like with the sprites, they are kind of smooth. They are pretty detailed. So this is a high resolution character set. So if we, for example, look at the 8 here, we can see that it has small square pixels. Now, as I said, like with the sprites, we can switch between high resolution and multicolor. And just like with the sprites, when we're in high resolution, we can only have one color in addition to whatever the background color is. So I could change the color. Let's see. I'm gonna do this just to show you. So I could change the color of this B, for example, to white. Oops, that was the background color. Okay, there we go. So I could change this B to white, but I can't add another color because I'm in high resolution mode right now. So this is a high resolution character. But what happens if I change to multicolor? So let me do that. Now I'm in multicolor mode. So if you take a look at this one right now, you can see that just like with the sprites, the pixels are now twice as wide. So instead of 8 by 8 pixels, now I have 4 by 8 pixels, because the pixels are twice as wide now. So the point here is exactly the same as with the sprites, because now I can make colorful characters. Now, in order to use this as a character set with letters and numbers, this might not be the best idea, but you can do it. So for example, I can make this A here with multicolor 2, so extra color 2, and with extra color 1 I could give it some kind of shadow like that, something like that, and that A would look like that. And I could even add a third color, like yellow for example. But again, maybe not the best choice for characters like this, because making characters with just 4 wide pixels can be a little tricky, especially with characters like M and W, stuff like that. But when we start to make graphics, background graphics, that's what we're going to use our character set for. So we are not going to make our own letters, numbers, stuff like that. We are going to use the character set for making background graphics. So that's what we're going to use this for. And then this multicolor mode comes in really handy. So let's take a look at an example of a background graphics. So here I have started to make some sort of background graphics. Now, first of all, let's focus on the character set. So what I've done, I've kept the letters and numbers. So I've kept the original characters all the way up to character 63, because I still want to use text, letters and numbers in my game. And the letters and numbers are always going, the Commodore is always going to look at this area for that. Why? Well, because remember, screen code 0, that's an established thing. Screen code 0 is always going to be this character. Screen code 1 is always going to be this character. Screen code 2 is this, and so on. So that's just a thing. And if we need to use letters and numbers, we need to have the first 64 characters just set like default. Now we could draw our own A, for example, or our own letters and numbers, our own font, if you will. But the point is that we can't, as long as we need text or numbers, we just have to leave this area. So I started to make background graphics down here. The first one I just made a solid light blue in case I want to make some sort of sky or something like that. But over here, for example, now you can see that I'm in multicolor mode because I have 3 colors here and the pixels are wide. So here I made a little tile. So instead of writing a letter or a number, I drew a tile like this. And over here, that's 1/2 of a letter. That's the other half of a letter. So this is what we're going to use the character set for. Just drawing background graphics like that. But you might be a little confused here, because this, as you see, this is this is multicolor. So take a look at this one. I have 1, 2, 3 colors here. So it's obviously in multicolor mode. But what about this number 3 here? That's not multicolor. None of this is multicolor mode. So this might feel a little strange. So we have high resolution mode and we have multicolor mode. But in addition to having those 2 modes, when we're in multicolor mode, we can actually have high resolution characters as well. Now the thing that decides if a character is high resolution or multicolor is the color itself. So if we look at the colors here, you can see that it's just 8 colors now. You remember the Commodore 64 has 16 colors, but now I just have 8. That's because I've switched to multicolor mode. So now I can only choose between these ones. And I don't know if you could see it, but there are some small red dots here. They are meant to represent high resolution and multicolor mode. So the size of the pixel, is it a small pixel or a wide pixel? So those red dots are really small. But the point is that if we take a look at the E, for example, and if you can see this tiny little plus sign here, it's at the upper part of this white color. If I go down to this yellow one, now the plus sign is down on the lower part of this yellow color. So this upper part of the colors, that's high resolution mode. The lower part is multicolor mode. So for example, let me do this one. So now you can see I'm in this tile, and just like with the sprites, the extra colors are shared here as well. So the concept is pretty much the same. So we have extra color 1, extra color 2, and a character color. So pretty much like just like we did with the sprites. But what I want to show you now. So I've selected this character, which is this one, and it's red. So characters can also have just one color in addition to the extra colors. But right now we have red here, and it's multicolor red. It's the plus sign here is at the lower part of this red color. What if I click on the upper part of the red color here? Then you can see the character changed. It didn't just remove the colors, but the pattern changed a little bit as well. And that's because of the ones and zeros, if you remember from when we talked about sprites. So a pixel is just 1 bit in high resolution, but in multicolor, 1 pixel, that's 2 bits, which can of course be 0 or a 1 or any combination of those two. So that's why the pattern is changing. We don't need to go super into detail about that. But the point is that we have 8 colors, and each of those colors is a high resolution version or a multicolor version. So if I now click back at the lower part of this red color, you can see that now it looks just fine. I have 3 colors. So we have 16 colors. The way we decide this in code, if I say color 0 in my code, that's this one, high resolution black. If I say color 0, 1, 2, 3, 4, 5, 6, 7, 8, if I say the color number 8, it's still black, but it's multicolor black. So as I said, it might be a little confusing, but that's how it works. So we still have 16 colors, but from color number 8 we go back to the first color, but in multicolor mode. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that might get some getting used to, but when we start to work with CharPad, then hopefully that will make sense. So just to really drive home the point here, we could use normal characters for making graphics. So we could make some background graphics with the character number 2, we could make some mountains or bees, we could have something here with you just using E's and 1s and C's, you get the point, right? Or we could make something like this with the Petsky characters. Now there are actually some very old games that used the built-in Petsky characters to make games like this, and you can do that, but we are not going to do that. So we are going to make our own character set. Now you probably guessed that when we are looking at CharPad. So we are not going to use the built-in character set, we're going to make our own custom character set, which of course means that we have to change whatever's in memory for the Commodore 64. So let's take a look at the memory. So this might also be a little strange, but the Commodore 64, we're not going to go into detail about the character RAM because that can get a little confusing, but the character RAM actually lives here at address 1000. Now that might seem a little strange because right now I can see that area is green, so that's just free RAM, right? Well, yes. Here's the thing. So we have our CPU and we have our VIC-2 chip. If you remember, the VIC-2 chip, that's the graphic chip. Now those two, the CPU and the graphics, excuse me, the video chip, so the CPU and the VIC-2, those see the RAM a little differently, which means that there's actually some stuff, let me use a different color, so there's actually some stuff down here. So we could almost say that there's a parallel universe here. So here's the thing that I've drawn here is what the CPU can see. So what we're actually going to care about, where we can put our code or whatever. But there's also this thing where the area where only the VIC chip can read. So this parallel universe down here is not something that we can use to store code or anything like that. So it's not like we have twice as much space. So we don't have 128 kilobytes or anything like that. But the VIC chip, when it reads address 1000, let me remove this so we won't get confused there. So when the VIC chip, the video chip, reads address 1000, it sees something down here, which is the character set. If we read address 1000, we would just get our code or tables or whatever we have stored in here. So that's the CPU. The CPU reads this part, the VIC-2 chip, so the video chip, reads this part. As I said, this can get confusing, so let's not worry too much about this. My point here is that the default address for the character RAM is at address 1000. Now we are going to use another address for the character set. So we're going to place it at the second half of address 3000. So in other words, 3800. This area, that's where we are going to cram in our character set, because we are going to use this area before it, right before it here. We're going to use that area for sprites. So we're not going to get too much into detail about this because this is the topic for another episode. But the reason I'm talking about this right now is because we need to be very aware of what I talked about earlier, the size of our character set. So if I open up my calculator now, I said that one character graphic, that's 8 bytes. So 8 lines of pixels for one character graphic. So 8 bytes for character A, 8 bytes for character B, and so on. So what if I multiply that by the entire character set? So that's 8 bytes times 256 characters. And then we end up with this. So a complete character set. So 256 characters, a complete character set like this. Oh, don't worry about this blank area, they count as well. So down here I still have 255. So 256 characters, that's a complete character set. That takes up 2 kilobytes. So that's something we need to be aware of. And 2 kilobytes, that's 800 in hexadecimal. So we are going to place our character set at address 3800 here. So it's going to fill up the last half of address 3000 here, from address 3000. From 3800, that's where we are going to place our character set. So a character set takes up 2 kilobytes, a complete character set. Now, as I'm sure you've noticed throughout this course, there's a ton of stuff to remember and a ton of stuff to understand and so on. But please don't worry. I promise you, if you just practice and work with this stuff over time, things are going to make sense and you're going to remember these things and so on. So just hang in there. But I just want to mention one more thing, just to cram one more thing in there. So we talked about the default character set, and that's this one. But there are actually 2 character sets in the Commodore 64. So we have this one with uppercase letters, so uppercase letters and numbers, and a few these pesky graphic characters. Now, there's also something called a mixed character set. Now, the mixed character set is something you would usually use in basic programming, for example, or just writing something. But I think it's important that we know that it's there. So if you switch character sets, so this is the default character set, writing with capital letters. But if you switch character set on the Commodore 64, you can get both uppercase and lowercase letters. So for example, if you would want to write a letter or whatever, then you could switch to this character set. As I said, it's not going to be super useful for us in programming in assembly language, but I think it's important that we know that it's there. So 2 character sets, uppercase and this mixed character set. All right, well, once again, this is a lot of information, so I think we'll say that it's enough for today. So, see you next time. Bye bye.